Hi everyone. How's it going? It's been a while, Geeta. How are you?
Good. How are you, Maggie?
I'm doing okay. Hanging in there somehow. You
Very
know.
excited to see you today.
What?
Very excited to see you today.
Yeah, it's good to see you too. I didn't know you were in this class. Yeah. Give everyone a couple minutes. I think there's only like the five of us in here. So Dr. Swanson asked me to do a quick overview for all of y'all about by a quick overview, he means more like a really quick introduction of Tekla Structural Designer and ETABS. So that's what I'm going to do today, about half hour for Tekla Structural Designer and a half hour for ETABS, ETABS being the one that I know Dr. Swanson is planning on using more so than Tekla Structural Designer. So should be a good time. Yeah, I think I'm gonna go ahead and start now. It's like 12:31. Hey Joe, how's it going? Um, so before I start, if I haven't lectured in front of any of you before, feel free to shout out any questions that any of y'all might have. I don't mind if you interrupt me at all. It can be kind of confusing, and each program that I'm going to be going over kind of has their own little quirks, I guess you could say. Unfortunately, we're not going to be able to get too in depth just because, like, to really get familiar with the program, you have to use it, right? So I'm going to do my best to give you guys a quick introduction. And if you have any questions, go ahead, shout them out. I won't mind. Basically it. Let's go ahead and get started. Share screen. So the first one that I am sharing with you guys is going to be Tekla Structural Designer. Now, modeling in 3D especially, I have kind of like a process that I like to go through every single time to really just kind of make sure that you hit everything that's going to be important, that's going to streamline any project that you have. So I'm going to be going through the same process with both Tekla Structural Designer and ETABS, but it's pretty important to understand that how you do that within each program is going to be a little bit different. So first step in that process is going to be setting up your grids, levels, elevations, sections, plans, everything like that. When you open up Tekla Structural Designer, this is what you all should be seeing. Can you guys see my screen? Yeah. Anybody give me a thumbs up? Thumbs down? Cool. Awesome. So this is what you should be seeing in Tekla Structural Designer. This is the first one that opens up, and there's some stuff to get there before you actually are able to like use it in terms of like signing up for the program, making sure you get your student license, etc. I'm not going to go over that with you today because that's would take up all of the entire hour. So first thing you want to do though is you want to have a new project, which is what we had. So I'm going to click that. This is what comes up. You have a 3D view and you have what they call a base view. It's basically like your ground level view. If you go to model, then what you can do is you have grid lines. And being that most of the stuff you guys are going to be modeling in in this class especially is probably going to be fairly rectangular. So we're going to go to a thing called the rectangular grid wizard. So origin, it's going to be your bottom left of your rectangular grid. I like to start at 0, 0. Keep in mind, X and Y are going to be on the plane level. Z is always your elevation level. You can do a couple of different things. X and Z sometimes on the plan level, with Y on the elevation level. Although if you do ever have Y and Z on the plan level and X is your elevation, then I will judge you. Just know that because it's weird. So, you know. But gonna select the origin. Obviously you can select it on the screen or I can just say 0, 0. That's fine. That's what I want. So I'm going to ask it to generate all lines. I can do X, I can do just Y. I'm just going to do all lines for this one. So in the X direction, keep in mind with Tekla Structural Designer, it's not counting the number of lines that it wants that you want it to have. It's counting the number of bays, and that's the number of spaces between each line. So I'm going to go ahead with 4. I'm going to say 20 feet is a good length for this. Just because that's kind of what I had set up like a basic model prior. I want the direction to be positive X as opposed to negative X, which goes to the left. Pretty sure we all remember our grid lines. So that looks pretty decent to me. So the Y direction, obviously that's going up. I'm going to say I want this to be 16 feet instead of 13 feet. So you saw each of those bays now 16 feet. I'm going to say I still only want the 4 bays. You can have either alphanumeric or numeric grid letters, and that's something that you can also change later on if you realize that you messed up in setting this up. Go to click next. Rotation. This is a thing where, like, if I were to say 45 degrees, it's going to rotate that way. Obviously, I don't want to do that. I want 0. So I'm going to type in 0. And then the axis angle is basically the difference between each angle. So if I had 45, that's a 45-degree difference between my X and my Y directions. So you can really make things pretty simple to do some pretty complex things. It's rather intuitive in that sense. So I'm going to click finish. Here is my grid. Going to take a look at it in my 3D world. Now, something to keep in mind with Tekla Structural Designer is it's a little bit different than other programs where if you have 2 windows and you start a command in one window, it will not transfer to the other window. So just keep that in mind. If I were to want to add a column here in my 3D window and I go back over to my plan, you notice that that command is no longer active in the plan view, but it is still active in the 3D view. So that's something that just keep in mind as you go in and work. I know other programs, they do things a little bit differently. Revit, you can switch between windows or views and continue with the same command pretty seamlessly. I think eTabs is the same way. Tekla Structural Designer, unfortunately, is not. So next thing we want to make sure of is our construction levels. So what I want to do is I'm going to add like 3 levels. Now I want the spacing for the first level. I'm going to make that 24 feet, right? Not 24 inches, 24 feet. And then I'm going to make each one of these afterwards 14 feet and then 14 feet. Now you see this source here. I'm going to say that I want my levels 2 and my level 3 to be based off my level 1. And this is something that you can kind of change. I can say F2 if I want, and then F3, and then F4, and my base would be my G level, basically. Type is where it determines those levels to be. So top of floor, structural slab level, or top of steel. I prefer top of steel, but that's because I do a lot of steel stuff, and so that's usually how I model. Top of floor or structural slab level could be really, really good if you're focusing in like a concrete model. Also just a heads up, if somebody types a question or something and I don't see it, feel free to just shout out, because I'm looking at one screen and all of the Zoom stuff is like over on the other screen. So yeah. So what this means though is that my levels 3 and 2, or F4 and F3, are going to be based on my level 1. So I'm going to click OK. And one of the first things I'm going to do is I'm going to do a column, right? I'm going to come over here for actually the plan for that, because what I can do with that is I can say, hey, I want my column to go from my base level from the ground up to F3, just because columns tend to go usually multiple levels. One thing that you want to make sure of is that you always want to make sure you have the correct type of of material that you're using, concrete or steel or whatever, I can choose different grades of steel if I choose. I can choose different sections, but obviously right now I only have one section. Now with Techless Structural Designer, I have to add each different section separately, which is kind of not as intuitive as some of the other stuff. But let's say I'm going to need a W16 or W14 by 145, so I'm going to select that. I know that later on I'm going to need a W14 by 90, so I'm going to select that. Right now, I'm going to use W14 by 145. With Techless Structural Designer, before you place your columns, you can choose your releases. And I know this is something that Dr. Swanson has probably spoken to you guys about. My columns are I'm planning on keeping all of them as a fixed columns. So no internal releases within those members. I've already chosen my base level. I've already chosen my top level. There's a few other things that you can do here. Restraints being in terms of preventing buckling as you go on. But what I can do then is I can just kind of stretch all these out. And that is those are all my columns now. But let's say that I wanted, these three and these three columns to actually be rotated, because I wanted to make sure that they were moment frames, and I wanted to make sure that any beams going between them would result in columns going around the strong axis. What I can do is I can come down and I can rotate 90 degrees. So there's those three columns rotated 90 degrees. Looking back at this, here's my 3D. To rotate in 3D in Techless Structural Designer, you use your right click button, your right mouse button. So that's also just another little kind of like fun thing about Techless Structural Designer. Now keep in mind, Techless Structural Designer also gave me all of my restraints already. If I want to change those, I can. So I just literally pick that restraint or that base plate. And then I can say that I want it to be something else, and I can make it something else. Support. What I can do is I can say that the support I want to be a fully fixed connection. And now this is a fully fixed connection. This one is pinned. I'm going to undo that because I do actually want it to be pinned, but that's kind of how you go about changing the supports. The next thing I want to do is this is where I'm going to find all of my levels, and you pick this like little structure thing here. I'm going to go up to level 2 because I want to create columns for my level 2 to level 3, or my F3 to F4 section. I'm going to make sure I have the correct material. I want my base to be F2 and my top level to be at F3. And I want this lighter W14 section. So I'm going to do the same thing here. Now, you'll see that obviously these guys, again, I didn't fix those rotations. You can see that here. But I can do that again. It's not that big a deal. Just rotate 90 degrees and now they match. 1, 2, 3, going around that 90 degrees. There we go. So there's all of my columns. They're rather pretty, I like to think, because I just made them. So next thing that we want to do is we want to go ahead and add some beams. Make sure that we have the correct grade. Let's go ahead and say, this is saying a W16 by 36. I'd rather have a W18 by 55. So I'm going to select that one. Now, what I'm going to do, keep in mind that I had said F3 or level 2 was based on level 1, and it was the same as well as for those 3 levels that I created, right? So I'm creating these beams, and then I'm going to come back here, and because I had all 3 of these levels, based on the same level, it assumed like, oh, that means you want all of those structure components to be exactly the same. Cool. Now, if I'm put on all of those structure components and then I decide I want something different, what I can do is I can say, hey, I actually want this F4 level to be unique. So I can come back, I can say that, and I can say I want this one, and these two beams. I want those to actually be those different shapes that we had talked about. I want those to be W16 by 36, right? So now I have a W18 on the one below it and a W16 on that top level. But keep in mind, if I were to go back to construction levels and I were to say, oh, I made a mistake, I actually want that all to be the same, it's going to change these back to be the same as whatever I had prior. So it is rather intuitive in that sense, but at the same time, you kind of got to keep an eye on those types of things. I'm going to open up this plan because I want to create those minor beams in between the main girders. I'm going to come back to a beam, A99250. I'm going to choose that W16 by 40, select that. Now, I can't create systems of beams, unfortunately, but you'll see when I go to add a beam, I can choose one anywhere along these lines here in the distance, but it gives me basically pick points for the quarter, half, 3/4, and then the 1/3 and 2/3 section. So I'm going to do the 1/3 and then the 2/3 points. And then what I can do is I can select this and I can go over to edit and copy. And then I can literally just copy this all over. To make it a little bit easier, what I'm going to do is I'm going to select all of these internal beams that I just made, and I'm going to copy them down like this, instead of going bay by bay. Come back to my structure. Pretty nice, right? It's pretty set up. However, I do know that I wanted moment frames and brace frames kind of on my building, similar to the Tower of Terror, but just this is a smaller version. So knowing that, how do I put in frames? Well, here's the thing with Tekla Structural Designer. If you want an elevation view, that's what they call frames. So you create frame, and then you click basically whatever grid line that you want that frame to be. And then it will create an elevation or a section view of that frame. So over here now you see all of these frames were created based on the grid line that they were in. So grid line 1 is going to be the view of grid line 1. Tekla Structural Designer really kind of pushes you to work in the 3D view though, so I'm not too worried about it. I just prefer to work in plan in some areas and elevation in others, but the 3D view is really not that bad. I'm going to go ahead and add a brace though. I wanted to add a V brace, or not a V brace, I'm sorry, I wanted to add an A brace. A brace being that inverted V. Wanted to use a different design section. I wanted to use a square HSS. So I'm going to select that. And I wanted to use square HSS, let's say a 4x4 by half. So the way you do this is I've selected my section properties. I've got my correct steel, let's say a 992-50. So I'm literally drawing a box where I want my brace to be, right here. In Tekla Structural Designer, when you draw braces, you literally draw pairs of braces. It's not going to analyze correctly if you try to draw a singular brace and then a singular brace. And you kind of want to do this with each level, right? So what you first do is you create the plane. And there you go. And then what I can do is after this, can select all of this using control and select. And then I can come back over, I can copy it from here to here, and I can copy it over on the other side as well. It kind of disappeared on me, so yeah, there we go. It disappeared on me again, so what I'm going to do, I'm going to actually copy it this time without trying to rotate in between. But you see, even when I'm selecting these braces, that it's literally selecting the pairs of braces. It's not selecting an individual brace. Everything you do is going to be with these pairs of braces. Now, something that I had done with all of these beams is looking at these beams and looking at the releases. All of these beams were pin beams, but I mentioned wanting moment beams, right? So what I'm going to do is I'm going to select these two beams, and I'm going to say that I want those releases to be fully fixed on both ends, because I wanted this to be a moment frame. Keep in mind, everything should be the same, going from level to level, which means that this beam that I had not selected, but was on a floor that was based on the floor I had selected those beams on, is now fully fixed as well. So it means that everything's pretty decent. I have now all of my basic structural, but I still kind of need a floor, right? I need a floor, which means I can choose one of these guys. There are multiple different options. You can do a slab on beams, you can do a flat slab, precast, composite slab. That's something that I suggest you go onto Tekla Structural Designer and figure out what each of those means. I'm going to do a slab on beams. Actually, that's not what I wanted. I'm sorry, I wanted a composite slab because I wanted the profiled metal decking, which means it's a one-way decomposition. What does decomposition mean? Decomposition is basically which way you direct your loadings on a slab. So slab area load, obviously you kind of manipulate the load. So like, oh, well, it's going to go over to this beam and that's the load on that beam. You follow the load paths. That decomposition is basically the using of the load paths to determine the loading on other members. Where does that load go to is the decomposition. Instead of selecting bays here, because what it wants me to do is select bays, but I have a billion bays, right? I don't want to select bays because then I'll just end up with literally a billion different slabs. Yeah, that's weird. I don't want that. So I'm going to Control Z. So I'm going to, instead of select bays, I'm going to create my own. And I have to pick back the beginning point. And then that's it. Now, right now, my decomposition, this arrow that you see here, that's the direction of my decomposition. If I wanted that to be different, then I need to come down to my slab and I need to rotate it. There's literally a rotate thing that I just used like not that long ago. So I literally used it like this morning when I was going over this, and now apparently you guys, I can't find it. Here it is, because it's all the way at the top. That's why I can't find it. All right, so rotated it. Let's go back. So now you see that arrow is going in the opposite direction. Obviously, I didn't actually want it to go in the opposite direction because this is my short distance in the X direction, not the Y direction. But that's how you change directions for your slab if you need to. And keep in mind, all of these slabs are exactly the same. I could change one and it'll change all of the others. But if I want to just change the one, then I got to change my construction levels to no longer be dependent on the same level. Speaking of which, after we do all of that, we have our braces, we have our main beams and girders, we have our columns in, we put in our slabs, we've put in our secondary beams as well, but we haven't put in our loading. Now, loading on the roof is going to be different than loading on other places. So I'm going to remove that source level, that being F2 for that top level, what you would call the roof level. I'm going to say okay. And that's just so I can make sure that I get different loadings. I'm going to come over to the load tab, and it's got a bunch of these set up for you already. One thing you want to do is remove the calculation, the automatic calculation for self-weight, because it's not going to be nearly as, it gives you a lot less control. You don't want that. I'm also not going to include it in the generator. The generator is something I'm going to show you in a second. I am going to include dead, live, roof live. Not too worried about snow, but I'll go ahead and leave it there. Probably just remove it from the generator. If I want to add one, I'm going to add this in. I'm going to add in wind. I'm going to say, yeah, it's definitely a wind. I want to include it in the generator. I want to reorder this because I really just feel like wind should be up here by roof live. So I'm going to click OK. And there you go. There's wind. So I have a load group as well. I'm not really going to get into that. It can be a little bit complicated, but the combinations, this is where the generator comes in. Something that Tekla Structural Designer does pretty decently is it generates load combinations for you. And they're pretty simple to understand as long as you make sure that you have your source correct. Initial parameters, do I want to delete or replace the combinations that I have? I'm just going to delete all previous. I don't have any combinations, so it doesn't quite matter this time. Am I doing an operating parameter? Is this an erection loading or is this final loading? For this project, it's going to be final loading. So I'm going to click next. Now, I have the option to choose whether I'm doing allowable stress design or LRFD. I am doing LRFD. I do not need MLL. So I'm going to unclick all of the MLL. Now keep in mind that these are all of the loadings that you get from ASCE 7-16. I'm working with Tekla Structural Designer 2022 version. So that was before ASCE 722 came out. So 722 is not actually an option on this version. Whether it is an option in future versions, I would think it would be. I don't know if it's an option in 23. But it's definitely not an option in the 22. So this is all based on ASCE 716. So I've got all of my final combinations that I want. I can check my factors, make sure that those are okay. I can click next. And then it's also going to include service combinations. And that's just so you can check serviceability limits and things like that. It's fine. You can keep that. Go next. Now, NL is notional loading. That's something that is a part of ASCE 716. I don't need any of it here. I'm not worried about it. So I'm going to click next. Minimum lateral loads are something that is very similar to notional loading, but is found more in other codes like Singapore or Eurocode, things like that is where you'll find a minimum lateral load. It's basically the same thing as a notional load, though. It's just a small percentage of gravity loads that you use to, if you don't have a lateral load that you're considering at the moment. I'm going to click finish, and here are all of my generated load combinations. It's pretty nice. It's kind of nice. And if I want to double check it, I can click over here on the left, and I can see, oh, my load combination, this would be load combination 5, and I could say, oh, I have a dead load and I have a wind load. If I wanted to copy this and say negative, then what I can do is I could say -1 and then -0.6 for the service version. And that's it. I can say okay, and it works. Envelopes. This is something that is not that you can generate, but I usually like to just create my own. And also to show you guys, I'm just going to create my own. So I have all of my load combinations. I'm just going to take them over. Now keep in mind the load cases, also known as load patterns in SAP 2000, and you'll see later in ETABS. Those are all not able to be in the envelope. So kind of SOL there. But I'm going to click OK. Now I'm only going to do one actual load because it is already 1 o'clock. In order to do the load with Tekla Structural Designer, first you have to come down here. This is load cases, this is load combinations, this is your envelope, but you have to choose dead load. And let's say I want an area load. So I'm going to choose this guy. I want to add an area load. I want to say, let's see here, let's go with 50 pounds per square foot, right? And then I can click here. And because these levels aren't unique, it created on both levels. But I also know that I have an area load of 75 pounds per square feet for the roof. So this one's now 75 pounds per square foot. This one is 50. Lateral loads, so the wind load, what you can do is you can go over here to diaphragm and you can choose where that happens, and you can say, hey, direction 1 is 20 kips, and let's say I have a moment of 30 kip feet, right? And that's going to be right here. Something else to keep in mind with Tekla Structural Designer, a positive moment is clockwise. That is not the same as ASCE 7 notation. ASCE 7 notation dictates that counterclockwise is a positive direction. Tekla Structural Designer does the opposite, and they kind of jump through a few hoops to kind of figure it out. Now, I have 2 versions of loads here. Going to go ahead and analyze all. And then I'm going to come over to this view, my results view. But you don't see anything, right? Well, for one thing, I got to come over to a load combination, but I still don't see anything. You're like, Maggie, what's up? What did you do? First thing I want to do is I want to check my status. Everything has green check marks, which means it's all hunky-dory. But then still, what's going on? Well, I want to actually look at the results. I have to click results. If I want to see values for those results, I got to come over here to my text button and click values for results. And from there, I can change whichever combination I want to look at, or I can look at the envelope that I have, which will give me the envelope results. Now, what if you wanted your moment? Here's my moment frames. Obviously, here is my brace frames. You don't see a lot of moment there. It's pretty fun stuff, but keep in mind, I'm not able to look at my deflections in the envelope. I have to look at my deflections only in the load combinations, unfortunately. So I want to see the values for my deflections. Something else to keep in mind when you look at deflections, Tekla Structural Designer loves to revert to service level loadings. So that's service level factors. If you want strength level factors, you have to click strength. So that's something, it's another little quirk. But then you can just click through all of the different load combinations you have, or even just the load cases. So just from wind, this is what I have, this 1.1 inches of deflection here for this frame. So that is how Tekla Structural Designer works. It also has this pretty cool review button view. So all down here on the right, and it's pretty cool. It lets you look at a lot of things. Like if you chose to design members, then it will tell you things that are designed. It will tell you what is fixed and pinned in terms of releases, which is going to be really, really important for you guys, as I'm sure. Obviously fixed is this green. So these all have fixed releases, but the rest of these are pinned releases. So it's really intuitive in the sense that you can see immediately, like, oh, that beam was not supposed to be a pin, that was supposed to be a moment beam, and you can come in and fix it. So that's really it. That's the big thing with Tekla Structural Designer. It's pretty fun. Really quick, did anyone have any questions about that? Okay, I'm going to go with no. That being said, I'm going to move over here to ETABS. I'm sure Dr. Swanson has talked ETABS up like a million times, and that's because it's a pretty awesome program. What I'm actually doing right now is if you look at this top button here, I'm remoting in to the University of Cincinnati's computer labs. That's how I get access to ETABS, and I do so by either using the VPN or being connected to the UC Wi-Fi. And in being connected to the UC Wi-Fi or using the VPN to be connected to the UC Wi-Fi, I can remote in to the computer lab, and I can come in and say, hey, I'm definitely going to use ETABS. Open it up. This is what I see. I'm going to go ahead and click new model. I have some saved user default settings, but you can use built-in settings and change. Oh, you know, I wanted whatever AISC 14 steel. I chose 15 because it's what I use. AISC 360-16. Now this is ETABS 18. So obviously, again, some of the other things just aren't going to really be available, the more recent versions of things. Gonna click OK, and it's gonna say, hey, what do you want us to set you up with? Well, I'm going to start with the grid only because it gives me a lot more function. So in the X direction, I had 20 feet, and then I had 16 feet, and I had 4 bays in each. So that's 5 grid lines. Again, keep in mind, Technical Structural Designer counted bays, ETABS counts grid lines. How many stores did I want? I had 4 stores total. Typical store height was, I think, 12 feet or 14 feet. I can say 14 feet. But the bottom story height I had is 24 feet. So make sure that that's correct. With grid labels, you can start at A and then start at 1, click OK, and then click OK. So here is my grid for ETABS. Everything looks the same. You do not have to set up your elevations and sections, which is pretty nice. What I can do is I can say, hey, I want to have an elevation view of grid line A, and I can apply it. And now that's an elevation view of grid line A, and I can add a new window. And I can say, I still want this plan view of story 1, let's say. Okay, there you go. This is how I usually like to work. I usually like to work with a big window of 3D and then an elevation and a plan, because it really cements where I'm at in my model. When you get into more complex models, that's going to become very, very important that you fully understand where you are working in your model. So one of the first things I want to do is I want to draw columns. I like to draw quick columns. So I'm going to come over here and I'm going to say, I definitely want, let's say W14 by, let's say it was a 159, I think. Moment releases are continuous for my columns. So, and then I can just say, let's see, hold on, angle. I'm going to say 90. I'm going to do here, here, here. And then angle of 0 for here and here. Let's see. Now you can see these, sorry, it took me a second to adapt, but ETABS, if you shift and then middle click, shift and pan, that will allow you to rotate. Whereas Technical Structural Designer was the right mouse click, and so that is something that can take a second to mind flip for you. Now you see all of these sticks here. These are my columns. If I go to display options, because I want to make sure that these are actually correct, what I can do is I can go to extrude frames and apply, and now I can see the actual frames in ETABS. And I don't always necessarily need that, especially if I'm continuing to work in things. But that will allow me to just kind of like continue making sure that everything's correct. Now plan view, I'm going to go back to story 2, or actually what I'm going to do is I'm going to select all these guys, and I'm going to copy and then paste. Because I'm in plan, it's asking me how I want to paste them, but I can come over here, copy. Apparently I can't. I'm really sorry, guys. This is one of those things that it's literally just like a matter of adapting from one model to another. I'm going to go ahead and continue quick drawing columns, but I'm going to make sure that I'm on the correct plan view 2, and then continuous, same column. Now, obviously, if I have these columns here, what I can do, I accidentally did it the wrong way, right? I know that I need it to be rotated. So how do I rotate it after the fact? If you right click, then you get into this, that's joint object information. But if you right click, then you will see in here property modifiers, end releases, all of these fun things that you have. There should be a rotation section in here where you can rotate. And for some reason, I can't recall where it is. I'm very sorry. And that's pretty frustrating because I should know for that. So what I'm going to do is I'm going to undo, and I'm going to just go about it the right way again, the way I did it earlier. W14 by 59. I wanted 90 degrees for all of these guys, all of these guys, and all of these guys. Luckily, eTabs makes it fairly easy to do this. It doesn't hurt nearly as bad as it would in some other programs. Going to go ahead and click plan again, go up to story 3, apply. And keep in mind, my column command is still going, so I'm not too worried about it. I can just keep going with all of this. Let's see. Here we go. And then I've got somebody like texting me a bunch. Going to apply story 4, but I do want a W14 by 68 instead of the W14 that I had before. So now, using a different W14, I've got all of these guys. Going to rotate these guys. And then escape. Now I have all of those levels. Now, something that you can do with the levels, let's see. If you right click on the grid, you can add modify grids, and you can modify story data. You can have a master story, and this is going to be similar to Tekla Structural Designer in this sense. And you can say similar to your master story. And then okay, and then okay. Now, if I were to say all stories or similar stories, that's going to be really the way to get all of those columns going. So if I deleted these columns, and then deleted those columns again, I'm going to come back over to plan, story 1, apply. I'm going to say, hey, similar stories. That's going to be all those similar stories, right? And I'm going to say, I want to quick draw those columns. I want them all to be a W14 by 68. So story 1, now you see that they all went up to that roof. That's how it works pretty well with eTabs. So apologies, took me way too long to get there, obviously, now that I have. Next thing I want to do is I want to draw beams So frame, what kind of beam do I want? I want a W, not a W14 by something crazy, W18 by 35. Moment releases, I can do a pinned, or I can do everything. I'm gonna go ahead and draw all of these. I have similar stories going, so it's all the same. Something I really like about E-tabs is I can quick draw secondary beams. But let's say for a second, before I do that, I didn't have the section that I wanted. I'm going to come over here to define. I'm going to select section properties and frame sections. And from here, you can delete all of these properties that you don't want to use, right? And then I can say, well, I'm going to import a new property from the steel manual, and then I can say I wanted to import an HSS. Going to come down to the steel section shape. I can say steel tube. I'm going to say an HSS 3x3 by 5/16. So that's now imported, and it was not there before, right? I highly suggest importing all of your properties first straight up. Now that I have all the properties that I want, I'm going to come over here to my secondary beams. And I want not a W14 by 500, let's say a W16 by 40. Or I guess I didn't bring it in. So I'm going to go with a W16 by 31. Now I can say number of beams, I only want 2. Do I want it parallel to Y or parallel to X? Well, I want it to be parallel to Y right now. So I can just collect all of this. Now keep in mind my moment releases for these secondary beams were all pinned, as you can see. There are different ways that you can go about it as well. You can say instead of number of beams, you can say you have a maximum spacing between these secondary beams, which is a pretty decent way to go about it. And keep in mind, this is on all of my similar stories again, because that's what I have chosen. Just make sure that things are kind of the way that they're supposed to be, in the direction that they're supposed to be. I'm going to look at extrude frames to make sure that I can actually see that things are oriented the way that I want them to be. And it looks like I'm okay. So I'm going to uncheck that as well, because it's just fairly difficult to actually look at things and see things. Something else that you can do is you can then define what you call diaphragms. D1, you can add a D2. That's something that's going to be pretty awesome. You want to have a diaphragm defined, and then you want to define slab sections or deck sections. So I don't need a plank one, but I am going to go ahead and look at my slab one and see what's going on. I am going to go ahead and look at deck sections, which is what I'm actually going to use. So I'm going to show that one. That's going to be deck 1. This all looks good. Say this is my metal steel decking with filled concrete. I want that to be 4 inches, you know. Slab material, that works. Deck material, that works. You can define that as you want. And so what you want to do, so I want to make sure I'm on similar stories, my story 1, and I'm going to draw a rectangular floor. Similar to Checklist Structural Designer. There we go. There's my floor. Now, how do I know which direction it goes in? If I can click the correct things, then I can see it. That's something that you want to check. You want to see, oh, section property, I meant to do deck 1. That's what I wanted. And then you can assign actually that diaphragm to it. So you want to assign the diaphragm to it. That there's that arrow that tells me that it's rotated the correct direction. So any loads that I add to it are decomposed to the correct beams. And so the reason why I applied a diaphragm to my decking, now that I have everything kind of set up, I have my structure set up the way I want. If I wanted to do a different slab on the top roof, I can come over here and say, oh, just this one story is what I want to change. If I had chosen all stories and selected this, then it chooses all stories. You can see this dashed line over here. But I want them all the same. The reason why, though, is because I actually do want to have a different deck on the roof. So I'm going to go back to one story, and then I'm going to come back over to this assign button, and I want to assign a different diaphragm to that roof. I didn't add one. So I gotta go back, I gotta define my diaphragm, add new diaphragm 2, it's rigid. Okay, here I can then assign to this shell a different diaphragm section, diaphragm 2, apply. So, and I can make sure that these two also have the assigned diaphragm that I want, diaphragm 1, apply. So the reason I did that is because I needed to add a shell uniform load set. But what I want to do before that is I want to define my load cases and my load patterns. It's load patterns for ETABS, load cases for Tekla Structural Designer. Self-weight multiplier, make that a 0, modify load, because you do not want to trust ETABS or whatever computer program to do those calculations for you. I'm going to add new load. Got duplicate load pattern name. So right in here, wind. I'm going to say this is wind. Auto lateral load. I'm going to say this is user defined, user load. Add new load. I'm going to click OK. I'm going to define load cases. Make sure that each load case is correct, right? Going to click OK there, and then I'm going to define load combinations. So I can add default design combos, but really I usually just add my new combos. So if I say LC1, then I've got a load factor of dead loads 1.4. And then I want to add live load is 0. So I'm going to delete that. So I'm going to click OK and add new combo LC2. See, I've got 1.2, not 4.2, 1.2 for dead load. I'm going to add live load being 1.6. And that's okay. And then let's go ahead and add load combo 5, which means my scale factor for dead load is 0.9 and my scale factor for wind is going to be 1. I'm going to click OK. And then what I also like to do at the very end is I like to double check all of them, first of all. And since this is a really quick thing, that's why I'm kind of like trying to go through this really quick. I might go over time a little bit, you guys. It looks like we have about 6 minutes left. So I hope you're all okay with that. But continuing on. What you can do is you can then define shell uniform load sets. I want to add a new load set. I want to say D1 dead. I'm going to add, right? So load pattern is, let's say 20 pounds per square foot, right? And I'm going to add the live load, which is, I'm going to say 35 pounds per square foot, right? So you can click OK. And then I'm going to add a new load set for D2, for my diaphragm 2. Dead load, let's say, was 40 pounds per square foot. And then live load was, let's say, 10 pounds per square foot. I can say OK. And I'm going to click OK. And then what I can do is I can assign shell loads, uniform load sets. I can assign that to my diaphragm. So I can click apply. I need to select my correct diaphragms and click apply. And then OK. close. Make sure that this is all correct. I have a tendency to like triple check absolutely everything, you guys. So, and then here I wanted to assign shell uniform load set D2. So now I have my D2 applied up here. I have my D1 applied. Come on, mouse. This is unfortunately part of working on a remote computer, is it doesn't always necessarily like to listen to my mouse, which is pretty frustrating. But you can see here, this is my D1 load set, my D2 is up here. You can see those little monikers down below. Now something I'm going to do actually as well is I'm going to come back to these, not the load cases, I'm going to come back to the load patterns. And what I want to do is I want to modify lateral load. This wind load, this is where you modify the lateral load. What you can do is you can say FX on story 4, let's say it was what, 50 kips in a moment of, I think it was 20 and 30 was what we did, right? And then you can tell where it's going to be. This is obviously choosing the center of rigidity. And we had only applied it to roof for Technical Structural Designer, so that's all I'm going to worry about here for ETABS as well. I'm going to click OK, and then I'm going to click OK again. And what I want to do to double check this is I want to go to Display, Load Assigns, Shell. Everything looks okay. I don't have anything on wind to show me, so I'm going to display load assigns. Frame, I don't have anything to show there. It's the dead that I wanted to show. Apply. So this is where you see this is the dead load. I had 20 and then I had 40, right? So after this, what I can do is I've got to save it. You want to save everything pretty hunky-dory. I'm just going to save it to the desktop right now. Class model, save. And then after that, I can click run analysis, and it's going to run an analysis for me. What it's going to do is it's going to take its good sweet time. I'm going to get myself a cup of coffee, you know, maybe some tea, and I'll come back and it'll have been finished for like 10 minutes because I got distracted. Whatever you may feel happens. It's kind of like when you go to the bathroom while you're waiting for food at a restaurant, you know, then it always shows up, right? You should see, once it's actually done calculating everything, you'll see the deformed shape. Here it is. So this is kind of the part that's really cool to see. It's the deformed shape. Now, in order to see deformed shape do something else, what if I want to see the deformed shape due to combo 2? Well, I can come over here, I clicked this little deformed shape, and I click apply. And that's my deformed shape due to load combo 2. Load combo 5. This is due to that wind load and moment that we applied to story 4 in the load patterns. And that's pretty cool to see, actually. If I wanted to see instead forces, I'm going to come over here to this guy. This is like a little like moment diagram here. And then I can click apply forces. I asked it to show me the moment. Obviously I did not check all of my releases on all of my beams. Otherwise, these beams that are currently pinned would be fully fixed. That's something else that you're supposed to definitely go back and double check, but being that we're short on time, I opted for going quicker than not. But something you can do is, oh, I had messed that up. So I got to come over here. I got to unlock my model, right? That means that all of that analysis stuff that I had done, I'm deleting it. Something that also I didn't do is I also did not actually go in and put in my braces. so I can click my braces. And I realized I was like, oh, Maggie, what are you doing? I'm going to click an inverted V. I wanted that HSS, right? That's what I had chosen. And so I can click it here. I can click it here, and I can just continue all the way up. Obviously, these are pin connections. There you go. If I wanted to see elevation 1, now I want to check that this actual moment frame is actually a moment frame. So something else I'm going to do is I'm going to click display, and I'm going to say object assignments. I want to see where my releases are. So at my end releases, I'm going to apply. Oh man, this isn't supposed to have like end releases here. So I can right click this and I can say, oh, end releases. Yeah, I don't want any end releases. So I can go in and I can assign frame releases or partial fixity. And then I can click this one, I can click apply. Now there's no end releases. And I can do that with all of the frames that I wanted to be moment frames, right? Apply all of that. Now, if you want to add those releases back, oh, I didn't mean to actually do that one. So I'm going to go ahead and select that. I'm going to apply that. Now I have end releases there. Everything's hunky-dory. I'm going to actually reapply that to be a moment frame. So I'm going to click OK. But that's kind of how all of that works. Again, with supports as well, you can say restraints. That's your supports at the bottom. But I'm going to go ahead and reanalyze this really quick. Let it take its good sweet time. You know, drink my coffee, what have you. Good fun times. E-tabs is the one you guys are going to use most in this class. I can tell you that much. E-tabs allows you a lot more control than Tekla Structural Designer does. Tekla Structural Designer can look a lot fancier, and they're really both very easy to use. It's just a matter of getting used to them, I think. Which is the same for any other computer program. Keep in mind, SAP 2000 and eTabs actually end up using the same analysis engine. So that's something else to keep in mind. Now looking at the 3D section, I'm going to go ahead and apply this LC5. Oh, check it out. You know, these moment diagrams actually look semi-correct. So they look very similar to how they're supposed to. I've got negative and positive moments here. Now, if I wanted to see axial forces, I can click axial forces, and now I've got axial forces in all of these columns, which is really nice to see. If I wanted to see shear, I can apply to see shear. You can see how the non-moment beams versus the moment beams, you get a lot more shear. Now, if I wanted to look over here and I wanted to see that moment, now I can see it on just that frame. So that's pretty nice. Gonna go ahead. If I wanted to look at one in particular, I literally just go and I right click on that frame. And then I can say, oh, I wanted to see absolute values, or I wanted to see extreme values. And here you can see it's showing me my major shear and my major moments. If I wanted to look at axial, there's the axial forces within that beam. If I wanted to look at the minor forces, here's the minor moment, and then the minor shear, and then minor deflection. So, and I can change whether I want to see that for load combo 1, 2, or 5 that I had defined earlier. Yeah. So that's basics of eTabs. There's a lot more to it, a lot more that you can get into. I'm sure Dr. Swanson will have a much better explanation of some of this stuff than I do, especially with the lack of time that I had. I'm sorry that I ran over. Are there any quick questions that I can answer, though, of the people who are left? Sounds good, Joe. Anybody else? I know there weren't a lot of people here to begin with, which is, I mean, it's fine. But that's it. That's really it.
Thank you, Maggie. I don't have any questions. Thank you very much for your report.
Yeah, sounds good. I'm going to go ahead and get this recording as well of this class over to Dr. Swanson. I'm pretty sure he posts them all, I think. So he should be able to post this one for you guys as well. And I can send him my process as well, and he can give it to you guys. It's kind of just like a check sheet of all of the things I try to remember to double check whenever I do any modeling. That little process like thing. So
Okay, I have a class next, so I'll be going. Thank you.
it was good to see you, Kita. All right,
Thank
Sujal,
you.
you got any questions?
Nope.
Sounds good. Have a good
Thank
one
you.
then. I'm going to go ahead and stop screen sharing and I'm going to end the class.
Thank you. Have a good day.
No problem.